This week's episode is brought to you by last week's terrible weather. As I was working to prepare stories, we had a freak set of storms pass through. From golf ball-sized hail to thunder that shook the house, our environment made it clear it is mightier than us pesky humans. Or at least mightier than the roof on my house. While experiencing that in real life, I was also seeing press release after press release and article after article discussing climate change. This 1-2 punch of new science and the need for a new roof means this week we're going to touch on climate change in our closer look. I apologize in advance. It's not pretty out there. Unless you like storm chasing, then it's kind of the stuff of dreams at the moment. In addition to water and weather-related earth science, we're also going to take a new look at the expansion of the universe and news of planet-eating stars and an update on how small things in our solar system tend to get even smaller over time. Oh, and if you're watching this before April 8th, this is your final reminder. There is an eclipse coming. Get out there and look up. Safely look up. With eclipse glasses, unless it is precisely totality. And you should drive to the path of totality. Then you can look up with your naked eyeballs. But otherwise, practice safe science, people, and cover up those eyes. We have tips and tricks on our Instagram, so go check those out. This is Escape Velocity Space News. I'm your host, Dr. Pamela Gay, and I am here to put science in your brain. In trying to understand our universe, theorists can build models that describe how the universe formed as a mostly but not completely smooth distribution of matter and energy, and how it evolved into a lacy pattern of galaxy clusters and large-scale structures like walls of galaxies. These models are great, and we've seen bits and pieces of observational evidence that supports them. What we haven't had is a clear map of a large contiguous volume, at least not until now. In a new paper, researchers using the Gaia Space Telescope present an all-sky survey of the locations of over 1 million quasars. The most distant are shining at us from when the universe was just 1.5 billion years old. In maps of the distribution as a function of time, it's possible to see two things. The most distant galaxies are more smoothly distributed, and over time, the number of quasars both decreases and they clump up in the sky as they power down. For background, quasars are galaxies with actively feeding black holes in their cores, and that kind of behavior was much more common in the past. Over time, galaxies have both used up their excess material by turning it into stars and through other processes. And they have also lost material to their environment as it was pushed out by light pressure or pulled out by gravity. This map shows us how gravity allows areas that started out with just the smallest amount of extra matter to attract more and more material toward them. This also shows the slightly more dense areas get significantly more dense, while the less dense regions simply empty out. The slow demise of quasars with time means we don't get to see the local large-scale structure in high detail. To accomplish that, we have to use galaxies without active black holes, which means combining catalogs. And I'm sure that combination of data is in our future. For now, it's just nice to see our long-held theories so clearly coming into focus in this largest volume survey so far completed. This massive new catalog is published in the Astrophysical Journal with Kate Story Fisher as first author. Understanding our universe isn't a straightforward process. For every theory that appears to be beautifully proven out by the data, there is another theory, or 5, 10, that just don't work as they should. One of the most troubling data issues today is the discrepancy between expansion rates for our universe that are measured by looking at the nearby universe and those that are measured by looking at the cosmic microwave background. We have multiple things to look at in both eras, and in both eras, we have very precise values, and the values don't match. The current rate of expansion is called the Hubble constant, and the discrepancy in measurements is dubbed the Hubble tension. On a mission to demonstrate the accuracy of our measurements based on variable stars and supernovae is Adam Rees. As a graduate student, he was part of the team demonstrating the universe is accelerating apart, and he received a Nobel Prize along with his colleagues for this discovery. In the decades since, he has pioneered new ways to use the Hubble Space Telescope to get even more accurate measurements of Cepheid variable stars. And now he has used the JWST to verify the same tension found by the Hubble Space Telescope. As Rees puts it, quote, "We've now spanned the whole range of what Hubble observed, and we can rule out a measurement error as the cause of Hubble tension with very high confidence. With measurement errors negated, what remains is the real and exciting possibility that we have misunderstood the universe." End quote. There are 3 largely watched places where this tension may get resolved. This paper only demonstrates that our measurements of Cepheid variables are consistent between all our different telescopes of improving quality. It remains possible that our supernovae data is biased in ways we haven't discovered yet, although that looks less and less like the case. It's also possible the expansion rate changed at some point in our universe's history, and our current models just don't allow that change. And of course, it could be that there is something missing entirely from our understanding of the early universe, the later universe, or everywhere. And we'll need to add that new physics to our interpretation of our data to bring the early universe and modern universe measurements into alignment. Time and more data will hopefully reveal the truth sooner than later. But for now, at least we know the variable stars are performing as advertised. Here's to hoping we can both use JWST to press outwards in our Cepheid variable measurements, and that future missions like the Roman and Euclid space telescopes will find other data to help us relax this tension into a new understanding. Data, at the end of the day, is our first and last source of understanding. We look, we build models to match what we see and predict things we haven't seen yet. And then we take more data to confirm those models. And sometimes the model is as simple as 2 stars born out of the same cloud of material should have the same composition. And new data shows us that in 8% of the binary stars in a 91 binary system survey, that just isn't so. In these systems that just have to be different, researchers found that one star looked just a bit different in a very specific way. It looked like it had been nibbling on planets or planetary disks. This is the first time we've seen younger stars with what appears to be former planetary material in their atmospheres. This kind of a chemical signature had previously only been noted on bloated elder stars that expanded out to eat their planets. This work is published in Nature with first author Fan Liu. This is your regular reminder. The universe is trying to kill us. And we're pretty lucky to be on a planet that's made it this far. Up next, we're going to take a jump from far-reaching surveys to instead look at the life and times of our ever-changing planet. Stay tuned. I've lived in my home for 17 years, which is the longest I've ever lived in one place. I like to garden, I participate in outdoor sports that are year-round, and this long-for-me timeline and familiarity with the outdoors means that I feel safe saying things are changing. After years of wondering which will come first, the last snow or the apple blossoms, the question has now changed to which will come first, the AC needs turned on or the apple blossoms. Tornadoes now hit in December, and hail the size of golf balls has hit the county twice in 1 month instead of twice in 1 decade. In talking to our roofer, I'm learning that insurance companies are changing from having deductibles to just prorating the cost of things, like what happens with cars, because weather-related damage is becoming too common for their prior business models to keep working. When I first became deeply worried about climate change in 2003, I, like many, thought climate change-related disasters would be far in the future, 2050 and beyond. But globally, the changes are happening now. They are happening fast, and it is time for an update. This is your periodic reminder. Earth is a planet, and we have to study it, even if we just want to focus on what's going on beyond the clouds. Well, our world by percentage doesn't count as a water world. The surface of the planet is dominated by the ocean and the flow and pooling of water across the land masses. To truly understand how climate change will affect us, let's start with ocean levels. A new NASA release finds global average sea levels rose by 0.3 inches in 2023 due to a warming climate encouraging the development of a strong El Niño. To put this in perspective, they explain this is the equivalent of emptying a fourth of Lake Superior into the ocean. Except this didn't require extra water from something like melting glaciers. This effect was driven by extra heat. According to Josh Willis, a sea level researcher at NASA JPL, quote, "In El Niño years, a lot of the rain that normally falls on land ends up in the ocean, which raises sea levels temporarily," end quote. But not all changes are temporary. Since 1993, a total sea level rise of 9.4 centimeters, or almost 4 inches, has been seen, with seasonal oscillations related to temperature. It is anticipated that by 2040, we'll have more than an 8-inch rise. While this sounds like next to nothing, this kind of rise will flood lowland marshes, glades, and wetlands, essentially reclaiming swaths of coastal states and nations. This will devastate historic cities like Venice and New Orleans and impact millions in megacities like Jakarta, Shanghai, Mumbai, Hong Kong, and Bangkok. As fellow JPL sea level researcher Ben Hamilton points out, quote, "Long-term data sets like this 30-year satellite record allow us to differentiate between short-term effects on sea level like El Niño and trends that let us know where sea level is heading," end quote. And that sea level is heading up. And it's not just ocean levels that are changing. We are slowly, or not so slowly, depending on your way of thinking, rearranging the distribution of water on and in our planet. While it's possible to mechanically measure, in some places, the amount of water in aquifers and the changing depth of the water table, to assess the entire planet, we need satellites. Currently, the GRACE FO1 spacecraft pair are circling the Earth and measuring the increases in gravitational pull that occur whenever they are over a region that has enhanced density. By orbiting over the same path over and over, year after year, it becomes possible to see how water tables rise and fall. And to ensure we have continued access to this information, NASA and the German DLR have announced they are collaborating to build the next generation pair of spacecraft. Past data from the GRACE mission have precisely measured the ice loss in Greenland at 280 gigatons and 67 gigatons from Antarctica in the window from 2003 to 2013. They have shown the change in mass distribution from the 2004 Indian Ocean tsunami as the Earth's crust shifted, and they have helped measure the more subtle variations caused by droughts, flooding, and other redistributions of water in the landscape. To the great frustration of anyone tasked with budgeting for the future, spacecraft, which are extremely expensive to build and launch, are really our best way to monitor our world. Unfortunately, it just isn't in the budget to build satellites the way we used to. But some researchers are finding other ways to get the data we need. In a new paper in Geophysical Research Letters, researchers led by Yangzhu Yang discuss how they have figured out how to incorporate existing data in new ways that can predict significant weather events. Currently, microwave data obtained from low Earth orbit satellites is, for the most part, not used in the major computer models that provide our weather forecasts. Infrared images, which tell us where cloud tops are located and effectively trace clouds in clear skies, well, those are the norm. Microwave data, however, can map out the distribution of clouds at all altitudes and provide the density of moisture as a function of altitude. In their new study, this team integrates microwave all-sky brightnesses into updated models and then challenges the models to reanalyze historic data and create predictions that can be compared against what we know has happened. And the model worked. According to Zhang, in looking specifically at the 2020 Midwest derecho, which damaged a large swath of the northern U.S. and southeastern Canada, they found, quote, "The computer model is able to produce a series of forecasts that consistently emphasize the most powerful storms and strongest wind damage at where it happened," end quote. In areas with ground radar and a large density of weather stations, this is good news, but it won't make a huge quality of life difference. For places without that equipment, this can mean survival when the nastiest storms are on their way. As Zhang goes on to explain, quote, "If we have this kind of information in real time before the events occur, forecasters might be able to pinpoint where the strongest damage is going to happen," end quote. And as my roof can tell you, damaging weather is becoming more common. Luckily, I have a new roof coming and a house that has withstood Midwestern storms for 140 years. I have a couple leaks, but some paint and a new roof will get everything fixed up, and until then, the leaks aren't that bad. In other places, construction didn't have severe weather in the plan. As Zhang explains, quote, "We know that there have been several times in the past several years in West Africa where very strong torrential rainfall events have brought on a lot of precipitation to those countries. And one thing about these countries is that they are also the places that will likely be impacted most by global warming. So I think if we can use these available satellite observations to provide better forecast for these regions, it will be really beneficial for the people there as well," end quote. We can't expect to see our weather prediction software making big changes to incorporate this data in the near future. But we at least see a path forward that may make living on a changing planet a little bit easier. No new satellites required. Climate change is one of those things we need to accept, plan for, and budget for. The next generation isn't going to have an easy time of it. But with enough data and science, we will continue on into the future. Up next, we're going to look at the past 2 weeks of rocket launches and what it means for comet debris to face the heat. Stay tuned. Our aerospace correspondent, Eric Mattis, is in the midst of eclipse travel prep, so this week I'll be bringing you the news he prepared with all that is new from the launch pad. On March 14th, SpaceX launched their third Starship Super Heavy stack from their spaceport in Boca Chica, Texas. This mission was another suborbital flight with test objectives to demonstrate in space restart of the Raptor engine, which is needed for a full orbital flight. SpaceX would also demonstrate cryogenic fuel transfer between two tanks on the Starship during coast. Instead of attempting a splashdown near Hawaii like the first two flights, SpaceX moved it up to the Indian Ocean. This would give them time to attempt the Raptor burn and still re-enter safely. On the day of launch, the countdown proceeded with no issues, and the vehicle lifted off at 8:25 a.m. Central Time. All 33 engines on the first stage remained lit during the entire first stage burn. Staging was nominal, and the first stage completed its boost-back burn without exploding like last time. Starship continued to nominal cutoff, also without exploding. After engine shutdown, it started spinning out of control, however, beyond the limit gas vent reaction control system to control. During its coast to the Indian Ocean, SpaceX did open the payload bay door successfully and close it. The propellant transfer demo was also attempted. This only exacerbated the spinning and made it rotate along additional axes. The booster successfully relit some engines to perform its landing burn, but exploded about 500 meters above sea level for an undisclosed reason. Starship kept spinning up to the entry interface. The 5 Starlink antennae provided enough connection to downlink very good views of the plasma bow shock on Starship. Starship kept spinning throughout, with the aero surfaces completely ineffective in the rarefied air. As soon as the vehicle hit actually thick air at 65 kilometers altitude, it broke apart, and SpaceX reported simultaneous loss of Starlink and TDRS connection. As is typical, the FAA announced a mishap investigation shortly after the flight ended, where SpaceX will have to develop and implement corrective actions prior to returning to flight. They hope to do so in the next few weeks. On March 20th, China launched a lunar communications satellite on a Long March 8 from Wensheng. Unlike the lunar navigation satellites I talked about last week, this mission was completely nominal. The satellite will insert itself into a 24-hour orbit around the moon to provide communications for Chang'e 4 and the future Chang'e 6 and 7 missions to the lunar far side. It is necessary because the first Qingqiao satellite is nearing the end of its useful life. The Long March 8 also carried 2 lunar ranging and navigation satellites, different from the failed DRO-A-B satellites launched on the 13th. These will perform their mission independently of Qingqiao 2. On March 21st, Rocket Lab launched their NROL-123 mission, named Live and Let Fly, from Wallops Island in Virginia. No details about the payload were disclosed. No recovery was planned or attempted. The launch was successful. On March 26th, China launched the Yanghai 302 satellite on a Long March 6A from Tianyang Spaceport. Yanghai 3 is a series of weather satellites from the Chinese military. The launch was successful. There were also 4 launches of Starlink missions. A cool launch this week that's worth talking about in more detail is Soyuz MS-25. It launched from the Baikonur Cosmodrome on March 23rd at 0:36 UTC. On board were a Russian cosmonaut, Belarusian spaceflight participant, and a NASA astronaut. The mission was supposed to launch on March 21st, but was aborted 20 seconds before liftoff on that day because of an electrical problem with the launch pad. The rescheduled launch attempt went ahead nominally, and the Soyuz docked 3 days later. Following the usual Soyuz rotation schedule, the Roscosmos cosmonaut and Belarusian spaceflight participant will return to Earth in the old Soyuz in 2 weeks. The NASA astronaut Tracy Dyson will complete a normal 6-month mission and return to Earth with the 2 Russian cosmonauts who launched in September 2023. Their mission was extended due to problems with Soyuz MS-22, which required MS-23 to be launched uncrewed. We're paying special attention to CRS-30 on March 21st. Unlike every previous Dragon 2 flight, it launched from Slick 40 at Cape Canaveral Space Force Station instead of LC-39A. SpaceX constructed a crew access arm at that pad for redundancy, and that capability allows for late load access to Cargo Dragon 2 as well. The launch was successful. Docking to the ISS took place on March 23rd. It carries 2,841 kilograms of supplies with it. Most of that pressurized in the capsule itself, but also 631 kilograms of equipment in the trunk. CRS-30 carries 1,135 kilograms of science equipment for the crew to perform. One is the latest in a series of plants in space investigations. This one focuses on 2 species of grass. Lawn grass. Scientists want to know how photosynthesis changes in low-gravity conditions and also how the plants themselves react to the stress of spaceflight. The results could help design a biologic life support system for a future space mission and techniques for growing plants in the difficult places on Earth. We track launches with the help of RocketLaunch.live. So far this year, the United States has had 34 launches, China has had 14 launches, New Zealand has had 4 launches, Japan and Russia each have had 3 launches, India, Iran, and Kazakhstan each have had 2 launches. This makes the total number of launches so far this year 64, with 1 failure and 2 partial failures. Finally, there are 10 toilets in space. Welcome to orbit, Soyuz MS-25. Before we go, I've got a bit of dust I want to draw your attention to. Back in 2007, Brian May brought newfound attention to the zodiacal dust in our solar system as he completed his long-delayed PhD. In the many years since his work, many people have asked, why is there zodiacal dust instead of something heftier, like zodiacal pebbles? The material that we're seeing largely originates from comets and is shed off in pebble-sized bits and bobs. Past theories suggested that over time these comet chunks got pulverized during high-speed collisions until they formed the nicely reflective dust we see today. But space is mostly empty, and in general, collisions require a fair bit of luck, or misfortune, depending on your perspective. In considering other options and reviewing what we've learned from bigger, more asteroid-sized rocks, it was likely something a bit more common, something like heat, might be a factor. In comparing streams of comet debris that pass through higher density regions and streams that get hotter, it was the streams that hit higher temperatures that crumbled to dust the fastest. I guess the comet debris can take the pressure, but just can't take the heat. And that is it for now. Good night, everyone. And remember to go out and look up and drive to totality. Okay, I guess you got one more reminder. Drive to totality. We'll see you next week. Bye-bye.